Good evening, all. Welcome to Infosys Coding Training Day 2. Am I audible? Just type yes, no. Yes, am I audible? Type yes, no. Is my audio clear? Getting my voice clearly? Say type yes, no in the chat. If there is any problem, let me rectify the audio. Is everything clear? Is everything fine? Audio and video looks good. So today we'll solve exclusively the questions given on 4th January 2026. Some of the students have appeared for Infosys exam on 4th January. So the questions which they got, okay, so on that day we'll solve those questions today so that it will be helpful to those who are going to write their exam on 18th January. Okay, so you will get some idea the standard of questions that will be asked in the upcoming examination. Okay, so Infosys question standard. So just type yes if my audio is clear so that I can proceed further. So thank you, Saket. What about audio? My audio, is it clear? So after this, I am going to start Python followed by data structures course using Python. Okay, so exclusively for those students. Okay, so 2025 batch, 2026 batch students. So this is the right time for their placements. Okay, so many students struggling in solving data structures problems. Okay, so that's why I thought of helping the students first by giving the training in Python. Okay, so exclusive training in Python. Then once that is completed, then uh, proceeding with the data structures and algorithms using Python. So that by next 3 months, those students who uh, appear for this training, okay, so they get some confidence in uh, getting a placement opportunity. So regularly uh, watch my YouTube channel. Okay, so please subscribe to my channel so that you will get updates, notifications about these training programs. Okay, so many students just text me on WhatsApp. Okay, so that's why I would like to help those students in Python and then followed by data structures and algorithm. Okay, so in detail I am going to discuss data structures and algorithm in detail. Okay, so that uh, you'll get full hands-on experience and you will be able to solve at least some 300 problems on lead code. Okay, so it would be helpful for you for these kind of examinations because many companies are recruiting through online examinations. Okay, so to get an idea about test cases, okay, then how to develop the logic and how to identify the problems, which kind of problem it is. There are different kinds of problems that also I'll discuss during uh, the data structures course. Okay, so all these things definitely are going to help the students in getting the placements. Yeah, if everything is fine, just say yes, I will proceed further. Okay, so let me share my screen if everything is okay. So we'll start solving one two problems, Infosys exam problems. Okay, so which were asked on 4th January. So just type yes if everything yes. Shall we proceed further? I'm not getting any chat replies. Please give thumbs up to proceed. So we'll start with the first problem that was asked on 4th January. So the first question, which was asked on 4th January. So this is the problem statement of that question. A group of n chefs. So there are n chefs. A group of n chefs had arrived at a cooking competition. Okay, so there has been a cooking competition, and for that, N chefs have arrived for that competition. The initial complexity of the dish they need to prepare can be described as an integer C. So here each dish they are going to prepare is described by an integer C. Yeah, is it clear everything? Screen and audio, just quickly reply one, two members so that I can proceed. Okay, so whether are you able to listen to me and see the screen quickly so that I can proceed further. Okay, then, right. So this is the problem statement. Okay, so group of n chefs has arrived at a cooking competition, and initial complexity of the dish they need to prepare is described by using an integer C. So each chef can be described by two integers e and m. Okay, so a chef is described by these two attributes e and m. Okay, so what does e mean? E is their expertise. E indicates their expertise in cooking, and m indicates their messiness in the kitchen. Okay, so messiness means the chef may not be uh, maintaining the kitchen properly. Okay, so cleanliness, or while preparing the dish also, so he keeps the things in disorder. Okay, so that all comes under a messiness. Okay, so how cleanly he prepares a dish and keeps the kitchen, that comes under a messiness. Okay, so that is given, described by an integer called as a m. Okay, and e indicates a expertise. Okay, and these two are integer numbers. Okay, so each chef is described with these two integer numbers e and m. Okay, then HF has two attributes given here. Okay, so the first attribute is expertise E. Okay, so this describes the expertise of the chef in cooking. Then messiness M. Okay, so the messiness in the kitchen. Okay, so these two attributes describes a chef. Okay, so this is the problem statement given on 4th January. As it is, I am just reading the problem here. And rules for cooking. Okay, so they have given some rules for cooking. What are those rules? Chef take turns one by one in an optimal order. Okay, so each chef takes one by one for their turn. Okay, so in an optimal order. We'll see what does this indicate. Then a chef can cook only if their expertise is at least the current dish complexity described by P. Okay, so that means the current dish complexity P should be less than or equal to E, expertise of the chef. Okay, or in other way, if the chef expertise is greater than the current dish complexity, okay, so then he can cook that dish. He can cook that dish. Okay, so that's why this statement we should read very carefully. A chef can cook when he can cook only if their expertise is at least the current dish complexity. Okay, so it should be either equal, or current dish complexity should be equal or less than the expertise of the cook. Okay, so then we can say that the cook can the chef can cook the dish. Okay, then after a chef cooks, then the dish complexity updates to max of p comma m. Okay, so here max is a function. Okay, so which gives maximum of these two integer numbers. Okay, so p is nothing but the current dish complexity, and whereas m is the messiness of the cook. Okay, so this messiness of the cook, so whichever is greater, with that then the complexity of the dish is increased or updated. Okay, so once a cook completes a chef completes cooking a dish. Okay, so this is the problem statement. So you need to understand these things very carefully. Okay, so initially it looks uh, what is this problem. Okay, so even though it is somewhat lengthy, but if you read 2-3 times, then definitely you can understand. Okay, so you should write down on paper what is given and what the problem is stating here. Okay, so here we can write down the glimpses from this problem. Okay, so n indicates the number of cooks or chefs, you can say. N indicates the number of chefs. Then each chef is described by two integers. Okay, so there are two integers e and m which describes a chef. Okay, so chef description you can just write down like this in your own words. Okay, so chef description is described by these two integers. Okay, so then there are rules. Each chef takes one by one turn, and this is another important point. Okay, so a chef can cook only if the expertise is at least the current dish complexity. Okay, so that means if the expertise of the cook is greater than or equal to current dish complexity, then we can say that he can cook the dish, otherwise he cannot cook. Okay, then after the chef completes the cooking. Okay, so then the dish complexity. Okay, so the dish complexity is increased to, now this becomes the complexity of the dish. Okay, so it will be maximum of these two numbers, the current complexity, then followed by messiness of a particular cook. Okay, so these are the rules given here. Okay, so we'll proceed further. Then what we need to do, so your goal is to find the maximum number of chefs who can cook the dish in an optimal order. Okay, so this we should understand here. So our aim is to find a maximum number of chefs who can cook. Okay, so that means you should optimize the number of chefs to maximum number. Okay, so here we should optimize these number of chefs to maximum number. Okay, so that means it we should maximize the number of chefs. Okay, so whenever we say maximize or minimize, okay, so this falls under a greedy approach. Okay, so that means we should be greedy about increasing the number of chefs. Okay, so this problem comes under a greedy approach. Okay, so how greedy we should be. Okay, so what is this optimal order, we should understand. Okay, so as we proceed further by looking at test cases, then you'll understand about this optimal order. Okay, so now here up to this part we understood that the number of chefs should be maximum. Okay, so maximum number of chefs, we should see that, we should let that the maximum number of chefs are allowed to cook the dishes. Okay, right. Then he has given some input format. The first line contains an integer n. Okay, so this is how the input is given, denoting the number of chefs. Then the next line contains integer c, denoting the initial complexity of the dish. Okay, so the initial dish complexity is indicated by c here. Then the next line contains an integer denoting number of columns in a. Okay, so each line I of the n subsequent lines after these two, then there will be n subsequent lines contains two space separated integers, each describing the row a of I. Okay, so that means a is an array. Okay, so a is an array containing two separated integers here. Okay, so two separated integers will be there. There is one integer here, there is one integer here, separated by space here. Okay, so like this the elements will present in this array a. What these numbers describe, we will understand. Okay, and these are the constraints. N should be between 1 to 10 to the power c, and these constraints. Okay, so then let us understand from the test cases. So test case 1, input is given this first line. First line indicates what? If this you should understand. Okay, so the first line indicates number of chefs. So this 4 indicates number of chefs here. Then the second line indicates what? The initial complexity of the dish. Okay, so the dish to be prepared, the initial complexity of this dish is C here. Okay, so then the next subsequent line indicates the elements in A. Okay, so this is the array A which contains these elements. Okay, so the elements are a pair here. Okay, so if you assume array A is an array, okay, or list in Python, so it is a list of lists. Okay, so like this, it contains these. Okay, so what these indicate that you should understand. Okay, so if you can identify what these numbers indicate, then your problem can be solved. Okay, so what this 5 indicates here. Okay, so each row of this A indicates what it indicates. Now see, it is given here. Each chef has two attributes. Okay, so a chef can be described here. He has given chef can be described by two integers e and m. Okay, so here we are given two integers here. Okay, so that means this is the description of a chef here. Okay, so since there are four chefs here, so this first chef, this indicates second element indicates second chef, next element indicates third chef, next element indicates fourth chef. So there are four chefs and each chef is described by these two integers. What these two integers indicates? The first one indicates the expertise of the chef and the second element indicates the messiness of the chef. Okay, so the first element indicates E, expertise of the chef, and the second indicates the messiness of the chef here. Got? Okay, so from this then you should get the output. Okay, so maximum number of cooks or chefs, how many maximum number of chefs they can cook for this dish whose complexity is C. So the final test case 1 output should be 4. Okay, so there are 4 chefs arrived and all the 4, okay, so can able to cook the dish with this initial complexity. Okay, so how to get this solution we will see. First let us understand all the test cases. Now once we understand the format of this test case, okay, so we will apply the same to test case 2. We will see whether the test case 2 is also following the same kind of structure or not. Okay, so let us find out here. This indicates n number of chefs 3 here. Okay, so this indicates initial complexity of the dish here. Okay, so then since the number of chefs 3 means there should be 3 rows indicating each row indicating a cook here. Okay, so this is cook 1 attributes, this is cook 2 attributes, and this is cook 3 attributes, and each attribute contains expertise and messiness. Okay, so given, right? So for this the output should be 2. That means how many number of chefs can cook? Out of 3, only 2 chefs can cook the dish with this initial complexity. We will see how to arrive at that. Okay, similarly the third test case. Okay, so 3 5 1 7. So number of chefs 3 means there should be 3 rows containing the 2 elements like this. Okay, so understood the problem? Any doubts in this? So you can just take the screenshots of the problem. Okay, so that you can read the problem 4-5 times and you can understand the problem. Okay, is everything clear? Got? Done. Okay, so if the problem is clear, okay, this is how you should work on problem. Okay, so at least 30 minutes you spend, okay, 30 minutes you spend on understanding this problem only. Okay, so what input test case indicates, and from this test case, input test case, as I said in previous video, so you should arrive at a output. for that particular test case. Okay, so on paper, if you can derive the output from these input test cases, okay, so then 50% of your problem is solved. Okay, so or not 50%, even 70% solution you got. Okay, the only thing is the solution you should convert that into only code. Okay, so only that conversion part remains. Okay, but 50 to 70% you should work on getting output from the given input test cases. Okay, so here you need to work more. So if you can solve this manually, then I'm sure definitely you code it, and your all your test cases will get through, will pass. Okay, right now. So we will try to understand the problem and we'll try to derive the answer. Okay, so we'll first work with the first test case here. Okay, so number of chefs are 4 here. Okay, then the initial complexity of the dish to be prepared is 5 here. Okay, so n value is given as a 4 and the complexity of the dish is given as a 5. Okay, so what he is saying, rules we should understand clearly. Okay, so rules for cooking, these rules for cooking: chef take turns one by one in an optimal order. This is first rule. Okay, so they come in optimal order, and a chef can cook, okay, so only if their expertise is at least the current dish complexity. Okay, so this is given, the current dish complexity p value is given to us. Okay, so then we should decide whether the chef can cook or not. When he can cook, if his expertise is greater than the complexity. Okay, after cooking, then the chef updates the complexity. Okay, so how he updates, or what the dish complexity becomes, it becomes the maximum of this p and m. Okay, so now let us solve this. Okay, so for example, number of chefs are 4 and initial complexity is 5 here. Okay, so this initial complexity, now you can say this as a p. Okay, so p is equal to 5. Okay, so first let us look at the first chef here. Okay, so what are the attributes of first chef here? First chef attributes I am taking here. Okay, so the attributes of first chef are 5 and 5. Okay, so the first chef attributes 5 and 5. So the first 5 indicates what? His expertise. The second 5 indicates what? His messiness. Okay, so the first chef, whether he can cook this dish or not with this complexity. Okay, so for that you should see that his expertise should be greater than or equal to p. Okay, so 5 greater than or equal to 5. Yes. Okay, so yes means the first cooker can cook. Okay, so for that what we need to do, we can count the value. So cook 1 can cook, that means the count of cooks becomes 1 here. Okay, so he can cook the dish, he can cook this dish here. Okay, so no issue, he can cook the dish here. Then next, after cooking the dish, what the cook will do, the chef will do? Okay, so he updates the dish complexity. Okay, so what is the dish complexity becomes? Okay, so the dish complexity becomes like max of p comma max of p is what? 5, and m is this chef's messiness. What is his messiness? 5 only. Okay, so maximum of 5 comma 5 becomes what? 5. Okay, so then the current complexity of the dish becomes a 5. Okay, so then we'll go to the next uh, chef. Okay, so they are coming in the order. Okay, so first we'll take them in order, then afterwards we'll find out what is the optimal order. Okay, so 5 5. Okay, so second dish, second chef attributes are 5 5. Okay, so what is his expertise? 5. What is the complexity? 5. Okay, so 5 greater than or equal to 5. Yes. Okay, so then second cook also, second chef also can cook. Okay, so that means here you add one more chef to count. Number of cooks becomes 2 here, chefs becomes 2 here. Okay, so then what is the current complexity? So this again messiness is also 5, so it is 5 comma 5 means it won't change. Okay, so complexity remains same 5 only. Okay, so then we'll take next cook's turn here. Okay, so the third cook comes here. Then what are his attributes? 5 and 5. So 5 equal to 5. Okay, so 5 greater than or equal to 5. That means expertise is greater than or equal to complexity. Yes. Okay, so that means this chef can also cook the dish. So that means we add one more chef to count. Number of cooks chefs becomes 3 here. Then increase, update the complexity. So since the second attribute of messiness is 5, maximum of 5 comma 5 becomes a 5 only, it won't change. Okay, so then we'll take a next chef's turn here, fourth chef. Okay, so again the attributes are 5 comma 5 only. That means the same condition becomes a true here. 5 greater than or equal to 5, that means his expertise greater than or equal to complexity. Yes. Okay, so that means this chef can also cook. Then add one more chef here. Okay, so then update the complexity. Okay, so complexity remains a 5 here. Then over, so the number of chefs over. So what is the maximum number of chefs they can count, they can cook? That means 4 here. Okay, so the output is 4. Got the output from this logic? Understood the logic? Logic clear? Is it clear? From the given problem statement, rules for cooking. Okay, done. So once the first test case output we identified by using some logic. Okay, so let us apply the same logic to test case 2. Whether it works for test case 2 or not, we will see here. Okay, so what is the A here? A indicates the attributes of chefs here. Okay, so 3 7 is first chef, then 3 6 is a second chef, then 6 8 is a third chef. Okay, so this indicates chef number 1. These attributes indicate chef number 2. These attributes indicate chef number 3. Okay, so 3 chefs, n equals to 3. Initial complexity is 3 here. Okay, so n value is 3 and initial complexity is 3. Okay, so that means complexity of the dish to be prepared, initial complexity or current complexity, you can say, is equal to 3. Okay, so now first the first chef turn will take. Okay, so chef number 1 turn, I will assume that chef number 1 turn first. Okay, so what are his attributes? 3 comma 7. Okay, so that means this is E and this is M here. Okay, so you check here whether E greater than or equal to messy or complexity P here. Okay, so E is what? 3. Okay, so 3 greater than or equal to 3. 3 greater than or equal to 3. Yes, that means chef 1 can cook the dish. Okay, so now you take a variable called a count, then add chef 1 can cook. No, so that means one chef can cook. Count value becomes a 1 here. Okay, so now we need to update the complexity. Okay, so the current complexity you need to update. What it indicates? Current complexity is nothing but maximum of P. What is current P here? 3 and the messiness of the cook. Okay, so who messiness of the chef who cooked the dish here. So messiness is 7. So maximum of 3 comma 7 is nothing but 7. Okay, so that means the current complexity of the dish increases to 7 here. Okay, so then we'll go to the second chef turn. Okay, so chef 2 comes for cooking. So his attributes are 3 and 6. Okay, so this is E and this is E. Now again you same test the condition here. E greater than or equal to P. So what is E of a second chef? 3 greater than or equal to P. What is the current complexity? 7. Okay, so then the condition becomes wrong. Okay, so that means his expertise is less than the complexity of the dish. Okay, so that means he cannot cook this dish. Okay, so he cannot cook this dish. Then we'll take the third chef turn. Okay, so third chef turn. So his attributes are 6 and 8. His attributes are 6 and 8 here. Okay, so again test the condition whether his expertise is greater than or equal to complexity. So what is his expertise? 6. 6 greater than or equal to 7? No. Okay, so that means chef 3 is not able to cook the dish. Okay, so he cannot cook the dish with this complexity because his expertise is less than the complexity of the dish. Okay, so he cannot cook such a dish here. Okay, so what our count value is 1, but what is the output we need to get here? We need to get a output as 2. 2 indicates what? Maximum number of chefs here. Okay, so the number of chefs who can cook the dish. Okay, who can cook the dish. Okay, but we got only 1. If you proceed in this order, we got only 1, but the output to be for this test case is 2 here. Okay, so that means somewhere we are missing the logic. Okay, so here you should catch that logic. Okay, so for that what you need to do, you need to, that means what you are doing, you need to understand the rules for cooking. Okay, so go back and check what are the actual rules for cooking. Okay, so rules for cooking is chef take turns one by one in an optimal order. Okay, so in the first instance generally we miss this statement. Okay, then we are okay with rule number 2. I'll give numbers here. Okay, so rule number 2 and rule number 3 we understood very clearly. Okay, so then you should concentrate on rule number 1. This we have not implemented in our solution. Okay, so what is rule number 1 here? Chef take turns one by one in an optimal order. Okay, so what this optimal order indicates here? So the optimal order is that if a chef, okay, so if a chef cooks a dish, we should see that the complexity of a dish should not increase. That means he should keep the complexity as low as possible, possible, so that we can let the maximum number of chefs to cook the dish. This is our greedy approach. This is called optimal order. Okay, so in greedy what we should do, if we want to let a maximum number of chefs to cook, okay, so we should always keep the complexity, this complexity we should see that after a chef cooks a dish, the complexity should not rise abnormally. Okay, so we should see that the chef increases the complexity or keeps the complexity as low as possible. Okay, so this we should understand from the problem statement. If you can derive this from the problem statement, okay, the meaning of this optimal order. Okay, here it is not mentioned that the chefs arrive or the chefs cook the dish in the order in which they arrived. Okay, that is not given. The statement is that take turns one by one in an optimal order. They mentioned that they take their turn one by one in an optimal order. Okay, so optimal order indicates that the cook with low complexity comes first. Okay, so cook with low dish complexity. Okay, so low complexity comes first. Okay, and similarly his expertise should be greater than or equal to the initial complexity. Okay, so these two we should send. If this is satisfied, then we should take consider only, because if expertise is less than the complexity, anyhow he cannot cook the dish. Okay, because he don't know how to cook such a dish. Yes or no? Okay, so if he is expert in the dish making. Okay, so that indicates expertise greater than the complexity of the dish here. Okay, so once this condition 1 satisfied, we should see that a cook with low complexity, okay, comes first for preparation of the dish. Okay, so in that order, in that optimal order, if you can send the cooks, if you can send the cooks, okay, so then it lets the maximum number of cooks to prepare the dish. Okay, so this is the very important point in greedy approach. Okay, so we should see one thing is maximum number of cooks should chefs can prepare the dish, and second one is they come in optimal order. Okay, so optimal order in this case, in case of chefs, optimal order is low complexity. uh, okay, low complexity chef comes first. Okay, a chef with a low complexity prepares the dish first, then next low complexity chef, then next low complexity. Okay, so that the complexity won't increase. So in second case what happened, now let us understand. In our test case 2, if we allow the chefs to prepare the dish in the order in which they appear in the list. Okay, so what is happening in the first instance itself, just you, if you observe, see here, if you observe the three uh, chefs messiness here. Okay, so the first chef messiness is 7 here, the second chef messiness is 6 here, the third chef messiness is 8 here. So we are allowing a chef 1 whose messiness is greater than the second chef messiness 6 here. Okay, so that's why these two chefs, because he is increasing the complexity of the dish. Okay, so this cook, this chef spoils the messiness here. Okay, so that's why for remaining chefs, they won't get, even they get the turn, but the complexity is increased, so that's why they were not able to prepare the dish. Okay, so now what we need to do, we need to arrange the chefs in, arrange the chefs in ascending order of complexity. Okay, so this way if you can arrange the chefs in ascending order of messiness. Okay, so the second argument is messiness m. Okay, so based on that, now I arrange the array here. Okay, so let us arrange the, so low messiness. Okay, so 3 6, that means chef number 2 comes first here. Okay, just I assumed uh, numbering for the chefs. Okay, so this is not, then next 3 7. Okay, so next messiness, that means chef number 1 comes next, then 6 8. Okay, then chef number 3 comes next. Okay, if this is the order in which they take their turn one by one. Okay, so let us now try to solve the problem. Okay, so first we'll take the first element from the array. Okay, so first element is nothing but chef number 2. Okay, so we uh, don't bother about these numbers. Okay, so because don't get confused here, this numbering is not important. Okay, so chef first chef with low messiness comes first. Okay, so that means 3 comma 6, these are his attributes. Okay, so what we need to test, whether e greater than or equal to p. So what is e here? So 3 is the expertise, then initial complexity is 3 here. Okay, so 3 greater than or equal to 3, yes. Okay, so then he can, this chef can prepare the dish, so count increases to 1 here. Okay, so then increase the, update the complexity here. So p you need to update, so p is nothing but max of okay, so initial complexity 3 and the messiness of this chef, it is 6 here. Okay, so then this becomes a maximum of 3 comma 6 is 6, this is current complexity. Okay, then we'll take the next element from the array here, next chef turn. Okay, so this is 3 7. Okay, so again check the condition here, E greater than or equal to P. Okay, so what this condition, E expertise is 3. 3 greater than or equal to current complexity is 6 here. So 3 greater than, no, that means the second chef from the in this order he cannot prepare the dish. Then take the third chef. Okay, so that's it. He cannot prepare. You just ignore this chef. Then go to the next chef here. Okay, so 6 comma 8. So check the condition, E greater than or equal to P. Okay, so what E indicates here, 6. 6 greater than or equal to 6. Yes, condition true. That means this chef can prepare the dish here. Okay, so then add 1 to count here. So count becomes 2. Then complexity updates. Okay, since the number of chefs over, then what is the output we got? We got the output as a count equal to 2. Okay, so which is equal to the test case 2 output. Okay, got. So that way if you solve, and if actually in test case 1, okay, so since the messiness are is same here and expertise is same, they again you should come back with this logic and apply whether the test case 1 is also satisfied with that logic or not. Okay, so in this case it is same anyhow, there is no much difference. Okay, but with different test cases, sometimes what happens, you should test again test case 1 also, you should test with the new logic. Okay, so that is what you need to do during the examination. So applying one logic for test case 1 and applying another logic for test case 2. Okay, another logic for test case 3, this won't work. Okay, so you should arrive at a single logic. You should arrive at a single logic by which all the test cases, okay, should be satisfied. 1, 2, 3, all the test cases should be satisfied. If they are satisfied with the single logic whatever you develop on paper, okay, so then 70% of your problem is solved. Okay, so the remaining 30% is just coding, converting the logic into code. That's it. Okay, so now let us apply the same logic to test case 3 here. Okay, so number of chefs 3 and initial complexity is 5 here. Okay, so our first aim is arrange the chefs in a ascending order of messiness. Okay, so messiness 6. Okay, so that means 1 6 comes first. Okay, so then 1 7 comes next, then 6 8 comes next. Okay, so three chefs, this is their order in which they take their turn. Okay, so that means the first person comes here. So let us just write initial complexity C. Okay, so which is equal to P, it is 5 here. Okay, so now we'll take the first chef turn here. Okay, so let me just write here chef 1 comes here. Okay, so this one with attributes 1 and 6. Okay, so then check the condition, E greater than or equal to P. So what is E here? 1. 1 greater than or equal to initial complexity 5. No, this is wrong. That means he cannot cook. Okay, so initially we'll take the number of chefs count as 0. Then we'll take the second chef turn. Okay, so 1 and 7. So if he cannot prepare a dish, then there is no need to update the complexity. Okay, so we update the complexity only when a chef can cook a dish. After cooking, he increases the complexity. Okay, so that you should uh, clearly understand from the problem statement. Okay, so next 1 7. Again check the condition, 1 greater than or equal to 5. No, so that means this chef also cannot cook the dish. Then take the next chef turn here. Okay, so next chef is 6 8. Okay, so 6 greater than or equal to 5. Yes, okay, so that means he can cook the dish. So increment the count value. Okay, so over. reached end of the array, then final answer, return this count value. Count is 1, so which is this. But okay, so like this you should work in understanding test cases and getting the outputs from these input test cases to output test case mapping you should do. Okay, so if you can do this for half an hour or 40-45 minutes, you take time, no issue. Okay, so you take time, okay, in solving or mapping input to output. If you can get this, okay, if you can derive this logic, okay, so hopefully I think now you are in a position to convert the logic into code. Easily you can convert the logic into code. Yes or no? How many of you support me? Just say yes or no. Understanding the logic, okay, so helps you more in completing the code. So I will show you the initial pre-written code how it would be, okay, but so type yes or no. Logic building, okay, identifying the logic solution on paper, okay, so you should work on paper. This is very very important. So be interactive. You can just send your queries if you have any doubts. Okay, done. So once we are done with this, okay, then this is the pre-written code. Okay, if you open editor in your online examination, so this kind of code appears on your screen. Okay, so you need to understand this code also. Okay, so what is given here? So he has defined a function called chef dishes with three arguments n, c and a. Write your code. Okay, so this part you need to finish. You need to finish this part. Okay, then def main a main function is defined here, so where he is reading the number of users, okay, and number of initial complexity c also is reading. Okay, so then he defined a list a here, then he is adding the attributes of the chefs. Okay, so this is pre-written code, no need to do anything with this. Okay, so this code is given to you, and this reads line by line system.stdin. Okay, so this read line reads line by line. Okay, say for example you are given the complexity like 3 6, Okay, so 3 7 not comma here, space separated. Okay, so 3 7 or 3 8 and 6 8. So read line, what it does, it reads the first line. Okay, then this strip removes the, after this you will have a new line character. Okay, so these new line characters will be trailing and before and after, if there are any white spaces or new line characters, they will be removed. Okay, then split will split these with the space as a delimiter. Okay, so it will split these two into two elements like 3 and 6, two strings you can say here. Okay, so those two strings will be converted into integer numbers. Okay, map function will convert them into integers, and it will be converted all this. Okay, and it will be converted into a list. Those two elements will form a list like this, 3 comma 6. Okay, and this 3 and 8, this is another list. Okay, then 6 and 8, this is another list. All these lists will be appended to the empty list A. Okay, so that means now your A is a list of lists like this. It contains these three elements. These are nothing but the attributes of the chef here. Okay, so then calling the function here in the code, chef dishes function is called, where n, c and a, these are passed as arguments. This function now should return a result. Then if you print the result, it is nothing but the maximum number of chefs, maximum number of chefs who can prepare the dish in that competition. Got it? Okay, so then inside the main is calling the main function, and in main function chef dishes function is called. So this piece of code you need to complete. This piece of code you need to complete here. Okay, so shall we write this piece of code from our logic? This logic we developed now. Okay, so we'll try to finish this piece of code. Okay, so let me write this function only. Okay, so this function code I'll write here. So let us write the code here. Okay, so we take another color here. Okay, so what we do is we'll define the function. Okay, so def chef dishes. Okay, so it is nothing but chef underscore dishes. This is the function he has defined with n as number of chefs, c initial complexity, a is nothing but a number of chefs with their attributes here, a. Okay, so this, so what we need to do from our logic, just see here from test case 3, if this is given, what we did here, the very first thing is we sorted them in. Okay, we sorted them in a ascending order of a messiness. Yes or no? Ascending order of a messiness. Okay, so the second attribute is nothing but the messiness. Okay, so we will first need to sort this array A here. Okay, so that we'll write here. So first thing is just I am adding a comment here, sort the chefs. Okay, so sort the chefs by their messiness. Okay, so then A is the array. For that, in Python, you have a function called as a sort function. Okay, so sort. So since our A is not a simple list, it is a list of lists. Yes or no? It is a list of lists like this. Okay, so 3 6 3 8 6 8 like this. Okay, if you understand this, see 1 7 1 6 and 6 8. Okay, so I'll write a sample here. It is given like this. Okay, so 1 7. This is how A appears, 1 6, then something like a 6 8. This is how the A appears here. So what you need to do, you need to sort this. A dot sort means sort the A in place. Okay, so when it is a complex object like this, list of list, then we should use a key. We should tell the Python by which element you should sort this. Okay, so since it is each element is again a sublist here. Okay, so this whenever we use key value should be a function. Okay, so here the best way is by using a anonymous function called a lambda here. Okay, so now you define an expression for lambda. It is nothing but defined by using lambda of x. Okay, so where from this x should be, okay, so x should be from the second argument. It is nothing but x of 1. Okay, so something like this, if x indicates the first sublist, for example, if x indicates the first sublet, this 1 is at index 0, it is indicated as x of 0, and this 7 is indicated as a x of 1. Okay, so this is our messiness. You need to sort based on this messiness attribute only. Okay, so that's why we are saying that take the key value as x of 1. That means the second element in the sublist. Based on that, now you sort this A. Okay, so when this statement is executed, okay, so when this statement is executed, now your A looks like this. Okay, so it looks like 1 6, then 1 7, then 6 8. So the list is sorted based on the messiness, second argument of the sublist. Okay, so once you got this sorted list, okay, so then what you need to do, you need to find out the current complexity. Okay, so that is nothing but p is equal to c. Initial complexity is given. Okay, so that we assign to current complexity. We understand that p indicates the current complexity. Okay, so since we have not started, initial complexity becomes the current complexity. Okay, so now you traverse through this array, getting each chef from this array. Okay, so then checking the condition whether he can prepare the dish or not. Okay, if he can prepare, then you update the complexity. This is what we need to do from the logic, yes or no. Okay, so each chef turn we have to take from the array one by one. That means you need to traverse the entire array. That means you need to run a for loop here. Okay, so run a for loop here for, okay, but this for loop now returns each element contains two values here. Okay, so each element is a sublist here which contains two values. That means you get two variables here, e comma m, for e comma m in a. So what this for loop will do is it returns each element from this a, and since each element contains two values, those two values will be assigned to E and M here. Okay, so that means this for first element 1 and 6. Okay, so this 1 is assigned to E and this 6 is assigned to M. Okay, so now you got the first chef from the list. Okay, so now what you need to do, you need to check whether he can prepare the dish, cook the dish or not. Okay, how? By checking the condition if his expertise is greater than or equal to the current complexity. Okay, so then we can say that chef can cook, chef can cook the dish, chef can cook the dish, he is able to cook the dish. Okay, so that means we got one chef now. So what we need to do, we need to define one more variable called as a count and initially to 0. Okay, so then we got one chef now. Now you increment the count value, so then say count plus is equals to 1. You say count plus is equals to 1. So one chef can cook the dish. So that means after cooking this dish, then what he need to do, he will update the complexity. Okay, so then the chef should update the complexity. Okay, so the complexity you should update here. So how you can update the complexity? It is nothing but the current complexity becomes p is nothing but the current complexity. Okay, so always p is equals to, so it is maximum of current p value, and the messiness is indicated by this m value here. Okay, So comma m. For that I am getting the two values here. So maximum of p comma m, whichever is maximum, that will be stored here. Okay, so then for in this case here 1 6. Okay, so 1 6 means 1. Okay, so 1 greater than or equal to, what is messiness here in this problem? What is messiness here? So current complexity is 5 here. Oh, sorry, messiness for complexity 5. Okay, so complexity is a 5 here. P value is 5 here. So 1 greater than or equal to 5? No. Okay, so this entire thing is inside the if statement. Please see here. Okay, so 1 greater than or equal to 5? No. So that means this chef cannot cook. Then what it goes to? Then for loop here, then it gets the next element that will be stored in E and M. So next element will be returned here 1 and 7. Okay, so E contains 1, M contains this one. Then again check 1 greater than or equal to P. E value is 1 here. 1 greater than or equals to 5? No, false. Okay, so that means E can also not allowed to prepare the dish. Okay, so then gets the next element. So for loop returns these values one by one until it reaches end of the list here. So this time 6 becomes E value and 8 becomes M value. Now check the condition. 6 greater than or equal to 5. Yes. Okay. So then means chef can cook the dish. Count value becomes a 1. Count is count plus 1 no 1. Then update the complexity. Max of a p comma m. So p is 5, m is 8 here. Okay. So then p value becomes a 8 here. Okay, so then end of the loop reaches, because end of the list reaches now. So then the for loop also terminates here. So once the for loop terminates here, then what we got the number of chefs. Okay, so that we are maintaining the number of chefs in a variable called as a count. So this count you should return. So exactly after coming out from the loop, so you return the count value here. So if you return the count value, that gives the maximum number of chefs. So what happens? This piece of code, if you write here, this piece of code, if you write here, this entire thing, main function is already given. Just you need to write this piece of code, whatever we have written, only this piece of code. Okay. So these comments I have added only for your understanding. No need to add these comments. Just you can write this code as it is. Okay. So then directly you can run your code. So how many lines? Hardly. It is 1, 2, 3, 4, 5, 6, 7, 8 lines of code. Okay. So if you can add these 8 lines of code, your first problem is solved. And see that whether all test cases are passed or not. Okay. So definitely all the test cases will be passed. So let us run this code. Okay. So let us uh, give these test cases as examples, as input to our program. Okay, whether it gives the same output or not, we will check. Okay, anyhow we have only public test cases. Private test cases at the back end, they'll have their own private test cases. In Infosys almost 12 to 15 private test cases are there, it seems. Okay, shall we run the code? So let me run the code. So here since it is executed, it is to be executed in their own online platform. Okay, so what we do is we'll open the Python IDLE. Okay, so I will open the Python IDLE and I'll show you how to. So open the Python IDLE. Okay, so type your code here. Okay, both entire code we need to type here. So quickly let me complete the code. So we need to type the entire code. So I am bringing the code. Okay, so this is our code. Okay, so in Notepad I typed the code and just copy pasting here. Okay, so you can just see here only this piece of code you need to write in the online platform of Infosys. And this is already pre-written code. Okay, so you cannot make changes in this code because their inputs will be from files. Okay, so internally their online platform reads the input from the files. All the test cases are stored in files. No, one by one it reads and checks whether your code satisfies all the test cases or not. Okay, so let us run the code. Okay, let us copy the input and output. Okay, so then how to run this in ideally? So just there is a run button here. Click on run module. Okay, then it takes you to command prompt where you should supply this command prompt you will get. Okay, so here you need to enter your input. Okay, so let us copy our input one by one. I will show for all the test cases. So it is waiting. Okay, so because read line function there we use now, so it is waiting for the input. So first test case input I have supplied here, and just let me enter this. Now you can see the output as a 4 here. Got the output 4 for the first test case. This is the output. Okay, so the output whatever we solved there. This output first test case output, no, right? See here 4555 number of chefs can cook 4. Okay, so let us try with the second test case. Okay, so now this is our code. Okay, so again we'll run the code and let us test with second test case. Okay, so again I am running the code. So go to run option, run the module. So again it takes you back to command prompt. So here it is waiting for the input. Okay, so you need to supply the second test case input. Okay, so test case 2 input will supply to this program. Okay, so I'm just pasting the input second test case, then enter. Now you can see number of chefs who can cook is 2 here, which is same as the output given in the problem. Yes or no? Just you can check here. Test case 2. See, output is 2 here. Okay, so we'll test with this test case. Output we should get as a 1 here. Okay, so this we'll do. So what we do is, again we'll run the code. One more time we'll run the code. So go to run option. Again run module. Now again it takes back to command prompt. Okay, so this is the command prompt. Here it is waiting. Okay, so it is waiting for the input here. So what we do is, we will copy the third test case input here. Okay, so all the input values will directly copy and paste here. So let me supply the input. Then if I enter, now you can see the output as a 1. Okay, so that means all public test cases, it is satisfying. We are getting the correct answer for all the public test cases. Once you get the correct answer for all public test cases, then you should submit your code. Until then, you should not submit. Okay, so there are two options, run and submit. Run is to check your code whether it satisfies all the public test cases or not. Okay, so if everything is okay with public test cases, that means your code is fine. Then you should click on a submit button. When you submit, then it shows out of 12 test cases, how many test cases have passed. Okay, if all the 12 have passed, then it shows accepted. That means your code is accepted. Then you can go to the next problem. See, out of 12, only 10 it shows the test cases passed and test cases failed, hidden test cases. Okay, so what is input output is not known to us, but it shows 10 test cases passed, 2 failed. Okay, those 2 test cases will be shown with a red mark, cross mark. Okay, so that means, so they have designed test cases in somewhat difficult way. So you should again go back to the constraints and read the constraints properly. Okay, read the rules properly. Then you need to modify. You should devise the test case, okay, such that your program where the test case failed, such kind of test case you should able to estimate. Okay, and make changes in your code. Okay, so what kind of test case is troubling your problem? Okay, so that you should estimate, and you should able to get such kind of a test cases. Okay, so this uh, you need to do. Okay, so to get all your test cases passed. Then, so if you have any doubts, if you have some previous Infosys problems which you need discussion of those problems, okay, so you can send those problems in the comment section of this video. And also please subscribe and share this video if you like this video. Help the students, your friends who are going to appear exam on 18th of this month. So click on the bell icon so that you will get updates, notifications for such a live classes in future. Thank you one and all.